All right, guys, we'll start where I left off. I had a whole nother like 5 minutes of video, and I realized when I got back there the battery went dead. So always check your battery before you make videos. It's a good rule of thumb. So we were kind of right about here. We were talking about a couple of different pieces, and I was relating it to cosine. We know that in the unit circle, cosine is x and sine is y. That means that as we go around, it's going to follow these signs. In here, it'll be negative cosine and positive sine. Here would be negative cosine and positive sine. Negative sine, sorry. Here it's going to be positive cosine and negative sine. So y's relate to the sines, even their values. Cosines relate to the x values on the unit circle. So this is cosine, this is sine. So they kind of start matching up. X is moving left and right, y is moving up and down. And when you draw your unit circle triangles in whatever quadrant, your y value is always your opposite, and your x value is always your adjacent. So that kind of leads us into, I think this was page 28 because I had erased it all. That leads us into what we're doing on page 29, which is finding, the first one is finding the cosine of 240 degrees. So, and I had it written on the other one. So remember, this is 0, 90, 180, 270, 360. So I know this value is between 180 and 270. So if I draw a small unit circle here, I know that this 240 degree angle is going to go from 0, going to go past 90, past 180, and stop somewhere in here. So this is 90, 180, 270. And I draw my terminal side. That means I already have my hypotenuse. Remember, the terminal side is the same as the hypotenuse. So then I just draw my triangle here. Here's my 90 degree, which is always across from the hypotenuse. And since I'm in quadrant 3, I'm going to do theta minus 180. So if you guys see that, theta minus 180. Theta is 240 minus 180 equals 60 degrees. So that means my reference angle, they call it theta prime, that is going to be 60 degrees. And then since that's 60 degrees, I have a special right triangle, which means that this is going to be 2. This is going to be negative 1 because my x value is negative 1. And my y value is going to be negative root 3. So I have my different values here, but I want cosine. So cosine of 240 degrees is equal to adjacent over hypotenuse. Cosine of 240 degrees, adjacent, negative 1, over 2. Cosine in 3 is going to be negative. It's negative, negative 1/2. That's my value for 240 degrees. I'm going to check the battery right now. Okay, battery's still working. Okay, so let's erase that one and deal with the 5 pi over 6. So we have 180 degrees, and we want the cosecant of 5 pi over 6. If you don't like this, convert it to radians. You guys are just going to have to realize that that's what converting it to radians is something you're going to have to memorize the conversion rate. And so cosecant is equal to 150 degrees. That 150 degrees is now in between 90 and 180. So if I redraw this, here's my 90, here's my 180, here's my 0. I'm going to go past 90 to right about there, draw my line, and there's my terminal side, which is now my hypotenuse. Draw straight down to the 90. I just need a reference angle. My reference angle is 180 minus theta. 180 minus 150 is equal to 30 degrees. 30 degrees is right there. Special right triangles tell me that 30 degrees has a side of 1, a hypotenuse of 2, and a adjacent of root 3. But the x value, up here, the x value is negative. So now I got to decide, what does cosecant equal? Cosecant of 5 pi over 6. Cosecant is the inverse of sine. So this is actually going to be equal to hypotenuse over opposite, which is going to be equal to hypotenuse 2 over 1, which is equal to 2. So cosecant, cosecant, erase that. Cosecant of 5 pi over 6 is equal to 2. All right, so again, we're starting to relate everything together. So hopefully that helps, and that gets you through 29. There's a couple of on your owns on the bottom.